Greetings. Welcome to the series on algebra. Now, algebra is using a lot of letters in problem solving, and before we get straight into it, I'm just going to go through a lot of common algebra terms. These terms I've organized together into the Tree of Algebra. So let's go through the tree, piece by piece. We start off at the bottom, right at the roots of the tree. And we have coefficients, pronumerals, and indices. Now, let's start with pronumerals. Pronumerals, just think of them like letters. Another word for pronumeral is variable. Pronumeral just means something which can stand for any number. So, some examples of pronumerals. X is the most common. Y, you can also have A, and you don't have to have English letters, you can have any type of letters like theta or anything you like. Okay, coefficients are when you see a pronumeral with a number out the front. If I had 3x, then the x would be the pronumeral and the 3 over here would be the coefficient. That means 3 lots of x or 3 times x. Now, coefficients don't have to be nice numbers, they can be different. We can have anything we like. Here we have negative 2y. The coefficient is negative 2. It's negative 2 times y. What that means, who knows? We can have square root of 3 times g. Square root of 3 is an irrational number, so it has an infinite number of digits. It's, well, there it is. Square root of 3 is the coefficient. We could have pi times h. Pi is our favorite number. It's 3.14, infinite number of digits. I memorized about 2 of them, and pi would be the coefficient in that case. Now, indices. When you hear indices, think powers. So, x squared. In this case, the pronumeral is x. The index, the power, is 2. It's x to the power of 2. 8a to the power of 4. Well, a is the pronumeral, 8 is the coefficient, and the index, the power, is 4. And you can also have any type of number for index. You can have a to the power of negative 3, a to the power of 1/4. You can even have something weird. You can have a to the power of b, or like b to the power of c squared, but as you get more and more powers, well, it looks ugly anyway. So, in these cases, negative 3 would be the index, 1/4 would be the index, b would be the index, and this is important, c squared would be the index, and c squared has its own index of 2. Okay, so when we combine a coefficient with a pronumeral and an index, we make a term. We list these things all together and they make terms. Here are some examples of terms. For this term here, we have coefficient of 3, pronumeral of x, index of 2. They all come together, they make a term. For this one here, no number's been written out the front for the coefficient, but we understand when it's written that way what we mean is a coefficient of 1. 1 times g is the pronumeral, the index is 4, power of 4. And you can have several pronumerals multiplied together. As a convention, we normally write the number out the front and then the 2 letters or the 3 letters or the X amount of letters all in alphabetical order because it looks nicer. So those are all terms, and when you add them together you make something called an expression. So see, we're building and building. We're going to be building on all this and making algebra. So let's take these 3 terms that I wrote. Okay, I've combined them. You can add them or subtract them. When you do that, this is an expression. Okay, so when you have 2 expressions linked together with an equal sign, you form an equation. Here's an example of an equation. So see, we have an expression on the left, an expression on the right. Just the 6 by itself is still an expression. It just has no pronumeral or index, that's fine. And they're linked together with an equal sign. So this is an equation, and I drew this little branch off to the side because there's a special type of equation called an identity. An equation can have one solution. It can have no solution. A solution is a value for x, which would make these 2 sides equal to each other. It could have more than one solution, but when it's true for every value of x or y or z or whatever, then it becomes an identity. This is called the Pythagorean identity. Cos squared of theta plus sine squared of theta equals 1. This is true for every value of theta. Theta is a Greek letter which is often used to represent angles. So cos of an angle, square that. Sine of an angle, square that. Add them both together. They always make 1 for every value of the angle. So that's an identity. All right, well, hope you had fun, and I'll see you around.